Alright, today we have another video on 9.5. It's called the multiplication with addition and subtraction method. It doesn't say this in the book, but again, this is another elimination method. Our goal is to get rid of one of the variables to be able to solve for the other one. So let me show you what I mean there. Our first example, we'll have two equations, so 6x plus y equals 6. And let's do another equation. This time I am going to put them in different colors because we're going to have to manipulate some of them individually. So we have 3x plus 2y equals 9. So 6x plus y equals 6 and 3x plus 2y equals 9. We'll call these equation 1 and equation 2. Now, if you recall from the last set of videos on the elimination method with addition or subtraction, the coefficients of the variables have to be the same in order for elimination to happen. For instance, if I add these two right now, well, the 6 and the 3 are going to become a 9, so that did not eliminate. The 1y and 2y are going to become 3y, so that didn't eliminate. So if we try subtraction instead, again, 6x minus 3x would be 3x. Does not eliminate. 1y minus 2y is negative y, so it doesn't eliminate. So none of the straightforward addition or subtraction methods are going to work here. So we have an alternative thing we can do, and that's multiply one equation or both equations by something to get coefficients to be the same. Remember, the coefficients are these numbers in front of the variable. In the case of this y by itself, that would be an invisible 1, okay, or a 2 in that case. So first, this 6 and 3 on the x coefficients from equation 1 and 2 look close together. If that blue 3 could be a blue 6, then that would allow me to eliminate the x's. So let's try that. So if I take equation 2, I'll just write it down here, which is 3x plus 2y equals 9. And I multiply both sides by 2, I end up with 6x plus, not 2, 6x plus 4y equaling 18. Now I have a coefficient on that x of 6, and if I bring equation 1 down here, let's just do, no, that didn't work. Okay, so I'm going to bring equation 1 down here, and it was black, so I'll keep it black. 6x plus y equals 6. I'll be able to eliminate those x's. Now, it doesn't matter. Notice in the beginning of the problem, equation 1 was on top, equation 2 is on the bottom. It doesn't matter what's subtracted or added to what. I can put them in any order I want. In this case, equation 2 is on top and equation 1 is on the bottom. Now I'm going to subtract, and 6x minus 6x, those go away. Those are now eliminated. 4y minus y is 3y, and 18 minus 6 is 12. We're going to divide both sides by 3, and we get y equals 4. So now I'm going to plug into one of the original equations. Neither of them look terrific. It looks like I might get a fractional answer here. I'm just going to plug into equation 2, because why not? So equation 2 is 3x plus 2y equals 9. Solving for x, I get 3x plus 8 equals 9, subtracting 8 from both sides, and then dividing both sides by 3, leaves us with x equals 1/3. So we think that the answer is going to be, and I'll put it up here so when I scroll back up we can see it. We think the answer is going to be 1/3 comma 4. Remember x and y in alphabetical order. So let's scroll up and see if we can do this mentally. We may or may not be able to do it mentally. Let's find out. Okay, 6 times 1/3. That we can do that mentally. So 2. 6 times 1/3 is 2. Plus 4 is 6. So it works for the first equation. And then 3 times 1/3 is 1. So 1 plus 8 is 9. So this is the correct answer after double checking. Let's try another one. Let's try 4s minus 5t. This will be example 2. And we have 4s minus 5t equals 3. Ray William Johnson. And then 3s plus 2t equals negative 15. Alright, so there's our two equations. I'll label them again. Equation 1, equation 2. The s coefficients are not the same. The t coefficients are also not the same. Not only that, we can't multiply 2 by a whole number to get 5. We can't multiply 3 by a whole number to get 4. So in this case, we're going to have to do a double multiplication. We can either try to turn both those s terms into 12, which would be the least common multiple of 4 and 3, or we could turn the t terms, the coefficients of the t terms into 10, which is the least common multiple of 2 and 5. It doesn't really matter. The last one we did was, I think, a subtraction elimination. So let's do an addition one by getting the t's together. So equation 1 was 4s minus 5t equals 3. Oops, I didn't do these in different colors like I said. Let's back it up and do that. It won't be too hard. 3s plus 2t equals negative 15. Okay, and let's write it again down here. Alright, so we want to get those t coefficients to be 10. So if I multiply the top equation, everything by 2, and the bottom equation, everything by 5, those t coefficients should turn out nicely for me. So let's see what we'll end up with. We'll have 8s minus 10t equals 6. And on equation 2, we'll have 15s plus 10t equals, ooh, that's big. What is that, negative 75? Okay. Now we can eliminate using addition, because we have a negative 10t and a positive 10t. So we'll get, we're adding, so 15 plus 8 is 23. Negative 10 plus 10 is 0. And then negative 75 plus 6 is negative 69. 23 does go into 69, which is nice. So we're going to divide both sides by 23, and we'll get negative 3. Now, we're going to plug into one of those initial equations, which are listed near the top here. I'm going to go equation 1. You know, sometimes there's a reason and it looks nicer. Sometimes they both look, you know, the same, so it doesn't matter. So equation 1, we have 4s, which is negative 3, minus 5t equals 3. And we're going to solve for t, so negative 12 minus 5t equals 3, and negative 5t, so we're adding 12 to both sides. Negative 5t equals 15. Dividing both sides by negative 5 gives us negative 3. And what we think our ordered pair answer is, let's write it up here in green, we'll call it ST. So -3 comma -3. And let's try it out. So in equation 1, we have -12 plus 15 equals 3. That works. And then -9 minus 6 in equation 2 is -15. So this one worked, that one worked, and this is the correct answer. Cool. All right, let's try another. Or actually, maybe I'll pause this video and go into part 2 for the next one.